Now we are going to do the training for our model. So in order to do this, we're going to use the train function. But first we have to identify the position where our response variable is currently at. So the position we already know that is, I'm going to put here in end call instead of training, R, end call R. That would be the output. And I'm going to tell it to show me the amount of columns that our matrix has until this moment, training norm. So this means that it's in column number 21. Very well. So from this point, we are going to do our model training. So I'm going to call it model RF. The function to use is train from the carrots package. And the first thing to indicate is where the input matrix variables are. These are all the variables that are contained in the matrix training norm with the normalized matrix, but I'm going to remove the response variable column. So I'm going to write minus and call R, and the response variable, I'm going to tell it what the position is. So I'm going to indicate that the position of N and call and R and call R. So now I could tell it which is the method that I'm going to use to train. I'm going to try a model with random forest and another one with neural networks. I'm going to show you now this web page, the carrot web page. I'm going to open a new window and I'm going to write here carrot package and R. And this is the web page. I'm going to leave it here. We also have the slides and everything, and there's an explanation that's pretty thorough about the different functions that this package has. This is a very complete package for doing data mining. We have examples, and honestly, this is very useful information that you can take advantage of in order to determine your models. I'm interested in this section where they show the different models that can be trained by using the carrots package. So there are many of them. I haven't even tested them. We have the ADA Boost, Bagged, Mars, etc., and the neural network. So this is where I got the information for those slides that I showed you before. So for this case, I want to do it with neural networks. So I'm going to search for neural networks. Let's see if I can find it here. There are many functions here for neural networks. This is the oldest package. It's the NNet package. So the method would be to use this word here, NNet. So in method, I'm going to write NNet to indicate that I'm going to work with neural networks. The arguments that this specific function have are going to be inherited by the trained package. So since this is a regression model, I have to tell it that I'm going to use line out and net so that it doesn't use a logistic model as a base, but instead of that, a linear model, telling it that I'm going to do a regression model. And remember that my response variable is quantitative. So this is a argument for neural networks within net. So I'm going to tell it that this would be equal to false. This is a base function, a linear base function. It's not always necessary to modify this. What you can do is to use the parameters by default. And I programmed some parameters here for random forest. And actually, the model that I'm training here, I was going to use it for random forest, but I'm going to change it for neural networks, as I said before in the beginning. And now I'm going to move this code line down here. And since I'm not going to tell it what are the parameters that I want to explore, it's going to pick ones by default, those possible values for the parameters. And it's going to try 3 different values for these parameters for size and decay. We're going to execute our first model. And this process is the one that is shown to us when we execute a neural network in R, and apparently some of the results couldn't be found. So I'm going to write here model nnet to see the results once it finished. And as I said before, it tries different parameters, and we can see the performance with the data set for training. So right here we have that it tried 3 values for size, the number of neurons for the hidden layer, and decay. Also 3 different values, and it made all possible combinations. So this is a value of our SME. The best model was with 5 neurons in the hidden layer, and a decay rate of 0.1, which tells us that the lowest value was this one right here in RMSE. So this is our model with neural networks. We could use it already to predict or to assess what are the most important variables here. I'm going to use the same model for random forest. So I think I can copy the same structure just as it is so that we don't have to program it once again from scratch. Now random forest. And what I want to change here is this to RF, random forest, RF. And I'm going to tell that I don't want neural networks, but instead random forest. And I have doubts on how I should use it. I'm going to check for it in the carrots page, random forest. The package is also called random forest. I could look for it based on the package. So here it is. But this is not the package I'm looking for. I want the simplest random forest package. No, I'm not seeing it here by default. I think that it's RF. Yes, it's this one. It's random forest with mtry. That's the random forest package. There are many libraries that are used, but this is the one that I commonly use. So I'm going to use RF, and this parameter is not necessary because it's for the neural networks, and the rest can be left just as it is. And however, since I chose some parameters I wanted to test for random forest, then I can use this argument that's called tuneGrid. And this is where I specify the different parameters. And by default, it's going to try 3, but I'm telling it what are the parameters that should be tested to generate the solution. Right. That error is telling me that I didn't execute that line. I'll execute it after. So random forest can take a little time to generate these results. So I'm going to be a little patient. And as you can see, it's very simple. Once we've already prepared our databases and we've carried out the processing that's necessary, the construction of these training models are a lot simpler. So once we've obtained the results, we can assess what's the performance. We can compare several models. We know that there are many different models available in this package that can be assessed. And what we're going to do after this, once we obtain the result of random forest, this is the script for neural networks and random forest. Now we're going to assess the performance, but with our data set for validation that we separated above. So we're going to keep on waiting for a while. Please try to be patient if this takes a little long, because normally the models can take some time to train. the more observations, the more time it's going to take. Now we're going to check the results, and it already tried the parameters that I told it to test, and we can see that there's our lower RMSE. The ideal one was with 20 variables in the mTry, and it had a performance of 0.08, the best RMSE. Compared to neural networks, we had a 0.12, and the R squared also increased to 0.79. Very well, so now we can assess the performance based on our data set for the test that was in the beginning.